In this video, I'll be introducing quantum chemistry. So, quantum chemistry. And what is studied by quantum chemistry is that instead of considering the electron just as a particle, it's also considered as a wave. So waves of electron. Like, for example, what happens to light. So in this case, you consider it as a wave. And the main formula you'll be using is C equals wavelength times velocity. So this is a good formula to know. And what each of the variables mean are that the C is the velocity of light. So velocity of light, which is 2.99 times 10 to the 8 meters per second. Although some consider it as just 3. Our lambda sign, which is this, is the wavelength. So it's the wavelength of, let's say, the electron. And that will be in meters. So the units is meters for the wavelength. And our last variable is the V, which is just the frequency. So don't get confused, don't think it's velocity, it's the frequency of the wave you're studying. And that will be in 1/second, or just second to the -1. So have that in mind. This V it means the frequency. Don't confuse it with the velocity. The V is actually a symbol pronounced nu, so that's why you shouldn't confuse it with the velocity. And the frequency can also be in hertz. I forgot to mention. That's the same as 1/seconds. And sometimes you'll use what is called the period, which is, so this is our period, and to define it, it's just the time to produce a specific number of signals. And if you want to obtain it, you just say the period is equal to 1 over the frequency, so our V, our new value. So it'll be, if you think about it, it's going to be 1/1/second, so it's just going to be in seconds. The unit of the period is in seconds. And if you wanted to know the definition of frequency, it's just the number of cycles per second. That's why it's in 1/second. Because a cycle, you don't consider it as a unit, so you just write a 1 or a hertz, just to give it a specific unit, if you can say. So now let's just solve a problem as always. It's actually a very simple problem using these equations. So in this problem we have a lamp that's generating a light with a wavelength of 589 nanometers. So our wavelength, our lambda, will be 589 nanometers. And the problem is simply asking for the frequency. I like writing frequency like that, but you can just write it as V, and just to stick with it. Let's just V or nu, and the period of the lamp, of the light, sorry, in the lamp. So as always, the first thing you want to check is your units. This is in nanometers. They usually like giving you wavelengths in nanometers because they tend to be very small. So a nanometer is simply, or a nano means 10 to the -9. So this will be 589 times 10 to the -9 meters. So let's get our equation. And it was that the velocity of light is equal to the wavelength times the frequency. So velocity of light is equal to wavelength times frequency, and we have this, and the velocity of light is always a constant. You said it's 2.99 times 10 to the 8 meters per second. So we just solve for the frequency in this equation. So nu is equal to speed of light over lambda, and that will be equal to, I'll write it here, 2.99 times 10 to 8 meters per second over 589 times 10 to the 9 meters. So that's just equal to 5.09 times 10 to the 14 hertz, or 1/2. So this is our first part, and now we want the period, and we said that I'll make it fit here. The period is equal to 1 over the frequency, so t is equal to 1 over nu. So our period will be equal to 1 over that, which is just, so that is just 1.96 times 10 to the negative 15, and it's in seconds. So that is how you use the beginning of quantum chemistry to solve a problem in which they ask you for period, wavelength, or frequency.